Now, we just finished looking at box and whisker plots and IQR, which is one way to explain where data is. You can say in what percentile it is. Now, a more common form of description is standard deviation and what's called a Z-score. So we can actually use the standard deviation as a ruler. Like I said, IQR tells you the middle spread, but what if we want to know if a point is more far away than we expect? Or what percentage of the data falls between 2 points? So in the next lesson after this, I'm going to actually teach you what percentage of data is between different Z-scores. For normal distributions or nearly normal distributions, which we'll be learning about, we can use a relative measure, which is the number of standard deviations away from the mean. So in this example, adult males are on average 70 inches with a standard deviation of 4 inches tall. Adult women are on average a bit shorter and less variable in height with a mean height of 65 inches and a standard deviation of 3.5 inches. Laura is 72 inches tall and Mike is 77 inches tall. Who is taller compared to their group? So first, how much taller than average is each person? That's what we could go with. Well, they're both 7 inches taller than average. Does that mean they're equally taller than their groups? You could look at it that way, but when we think about it, who is more unusual, we really need to know how far the data is spread out and how far out on the spread they are. So we're going to say how many standard deviations above average is each person, or their Z-score. So we basically say we're going to take the difference, which is 7 inches, divide by 3.5, and we find out that Laura is 70, there's a 72, there's a 65, and there's a standard deviation. And Laura is 2 standard deviations above average. We can do the same thing with Mike. So there's 77 comes from there, that's his height, minus the average, and the standard deviation is 4. So he's 1.75 standard deviations above average. So in this example, Laura is a little more unusual since the spread of female heights is tighter than the spread of male heights. And notice that you're always taking the actual minus the average because you want to know how much above average you are. Now, if you're below average, you're going to get a negative answer, and that actually makes sense. So Z-scores measure how many standard deviations the point is away from the mean, and this is the formula from your math chart. You might actually see it more like this. It's statistic minus your parameter and the standard deviation of the statistic. Or this could be actually your value. Anyway, so you take the distance and divide by the length of the standard deviation. If the Z-score is negative, it's below the mean. If it's positive, it's above the mean. So what do Z-scores mean? Let's revisit this cool app where we can see the actual data live and how the numbers change. So here we are with my points, and before we looked at the difference between the point and the mean. So if the point was lower than the mean, the difference was negative. If the point was higher than the mean, the difference was positive. Now to find the Z-score, all you do is take this value, in this case negative 6.6, and divide it by the calculated standard deviation. So 4 goes into negative 6.6, negative 1.65 times, roughly. I'm sure it's rounded. And as I move it around, so if I take this point and I move it further below, what happens to the Z-score? It goes down, right? As I move it up and it gets closer to the mean, the Z-score is getting closer to 0, becoming closer to positive until I get to the other side. And you can see that the Z-score is all the way to positive. So it's actually more than 1 standard deviation away. And I can get it less than 1 standard deviation away and then back to the negative side. So just looking at these Z-scores, you can tell I have a point at 2 points that are below the mean, and I have 3 points that are above the mean because they have positive standard deviation scores. Which one's the furthest away from the mean? Well, based on the Z-score, it looks like point A is the furthest away from the mean, and then point E, which kind of makes sense based on the picture. So let's go ahead and look at this practice problem. Amy scored a 1740 on the SAT and Maria scored a 30 on the ACT. The mean score for the SAT that year is a 1500 with a standard deviation of 240, and the mean score for the ACT is 21 with a standard deviation of 6. Who scored better? Hint, we're going to use the Z-scores because you can't use the actual scores. So Amy's Z-score is that 1740 minus 1500 divided by the standard deviation, which is 1 standard deviation above average. Maria's Z-score is 30 minus 21 divided by 6, which is 1.5 standard deviations above average. And Maria scored farther above her group than Amy did, so in a way she did better. All right, my mom has a height of 4 foot 11 inches. What is the Z-score for her height? And we're going to use that data we had from before, which actually I did find on a website. So we know that the average height for women is 65 inches or 5'5", and standard deviation of 3.5 inches. So I'm going to take 59 inches, which is her height. 5 times 12 is 60. She's 1 short of 60, 59 inches. So my mother's Z-score is negative 1.71 because you have negative 6 divided by 3.5. What does it mean when a Z-score is negative? The value is below average. Half of Z-scores should be negative. In this example, we're looking at Maya, Alaska, has an average September temperature of 32 degrees Fahrenheit with a standard deviation of 12.2 degrees Fahrenheit. Ohio, I'm probably mispronouncing it, Hawaii, has an average September temperature of 77.2 with a standard deviation of 1.5 because their temperatures don't vary that much. So last Friday, Umiya had a temperature of 20 degrees Fahrenheit and Ohio had a temperature of 70. Which location was colder than average? So to do the Z-score, 20 minus 32 divided by 12.2 is negative 0.98. In Hawaii, 70 minus 77.2, that's negative 7.2 below average, and divided by 1.5 actually has a much lower Z-score. So Ohio was colder than average. For our last example, we're looking at the average weight for a female backpack on the Camino de Santiago, which I'm familiar. All right, and we're assuming it's 14.5 pounds with a standard deviation of 1.5 pounds. Male backpacks typically weigh more, but they can have more variance with standard deviation of 2 pounds. Carla and Edward were both able to get their pack weights down to 12 pounds. Whose pack is lighter than average? So to calculate Carla's Z-score, we take her 12-pound pack weight minus the average for females and divide by the standard deviation, and we get negative 1.67. For Edward's Z-score, we go 12 minus 16 divided by 2, which is negative 2. So Edward's pack was lighter than average.